Okay, so we're going to get started here. This is going to be CCNP Root Lab 1, and in this lab we're going to configure RIPng and verify it. And what's going to be probably blatantly obvious as we step through the commands to configure RIPng is how few commands are necessary and how quickly this distance vector routing protocol can be brought up. However, what's going to be not so obvious is all of the internals that are making this routing protocol work. And so to kind of illuminate some of that, I'm going to make sure that as we get into this particular topology, and it's a very straightforward 3-router topology using IPv6 addresses on the serial interfaces. The link local addresses are going to be defined there pretty straightforward, just using a FE80::1 for router 1, :2 for router 2. But what's going to be really helpful is using both Debug and Wireshark captures to see the internals working in behind the scenes to make RIPng work. So again, it's kind of the objectives in this. I'll be enabling debug on router 1, might actually do some on router 2. Let's just keep it open. Debug could possibly will be used. I'll be using it on routers 1, 2, and 3. The reason I was about to exclude routers 2 and 3 is because between router 2 and router 3, RIPng will not be configured. Between those two devices, there are going to be explicit routes. From router 2 to router 3, there's going to be a default route, and from router 3 to router 2 is going to be a static route. So we'll take a look at those and see how that's all going to appear, looking at the debugs and the Wireshark captures. A big part of this exercise is supposed to be configuring the IPv6 addresses. However, what I'm going to do is I'm going to just kind of configure the addresses on router 1. I've already configured them on routers 2 and 3. Once you've gotten the hang of configuring the IP addresses and learning the caveats that can trip up, it's pretty straightforward. Probably one of the most important things, just to get some experience with doing it, so that the scale of the 128-bit IPv6 address doesn't catch you off guard. The more I've worked with IPv6 addresses, now it just feels normal to me. At the beginning, the address just looked so odd after having worked with IPv4 for so many years. But at this point, it's just another address, and very easy to work with. So let's see what we got. We're going to configure RIPng between R1 and R2. That's the third bullet there. Going to configure IPv6 static routes between R2 and router 3. Going to propagate a default route using RIPng from router 3 to router 2. Then we're going to examine the RIP processes and the RIP database. So it's pretty straightforward. Shouldn't take too long, but just before, I'm going to run through a couple of items here about RIPng. It is a distance vector protocol, has the persistent item that we've seen since RIP v1. Hop count limit is 15. Split horizon, poison reverse are used to prevent routing loops. RIPng is based on RIP v2, but however, unlike v2, RIPng will not work with RIP version 1. It is pretty much, I think, most folks would running any iOS that's 12.2 and the 2 train there should have RIPng. Let's see, next one. Yeah, some more. Now, this is some things that we'll actually see in the debugs, and in the Wireshark chapters I actually get to see these port numbers and these multicast addresses. UDP 521 is the port used by RIPng, whereas RIPv2 used the 520 port. RIPng also has this multicast update destination of FF02::9. Looks familiar to you? Should, because it's kind of borrowing in the image from RIPv2, which used a multicast address of 224.0.0.9. IPv6 with RIPng, there are some options in here for authentication, and I'm not sure if I'm going to do authentication in this particular video. Probably going to hold off on the authentication until either EIGRP or OSPF, where there are really sophisticated authentications involved, and so probably wait and do authentication within RIP until then, so we can actually be comparing EIGRP, OSPF authentication with RIPng. Let's see, is that the last one? Okay, so a little more here. Let's see. Of course, RIPng supports IPv6. That's that point I was making about the RIPng doesn't support RIPv1 updates. RIPng supports an authentication. Oh, yeah, then these last three are pretty important. If you remember from RIPv1, RIPv2, there was the network statement or the network command that was entered in the global configuration mode for the RIP process that brought into the network, enabled the interface that was associated with that address to participate in RIP. Well, the network command is gone, and in RIPng it's been replaced with there's the opportunity to actually configure the RIP process underneath the interface where it will be expressly running from. RIPng, unlike previous versions, RIPv1, RIPv2, RIPng will not be configured to run by default out of the box. Because RIPv1 and RIPv2 were IPv4 protocols, or were associated, routing protocols to run for IPv4, you didn't have to enable anything. However, with RIPng, IPv6 unicast routing has to be turned on. It is off by default. We'll actually see that on router 1. Let's see that also that the RIPng processes get named, which allows for me to have more than one RIP process, more than one RIPng process on the same machine. I've seen this done in kind of lab settings, and one of the things that's important to remember is that if I configure RIPng using different process instant names under the same interface, I need to change the port number. And I don't think we'll actually get into this in this lab. I'll make a note. We might come back and visit that at a later time. Because multiple processes can be configured, I'll leave it at this and say, because multiple processes for RIPng can be configured on one router, there are safeguards and additional configuration steps that need to be taken with regard to the port numbers to make sure that it works correctly. So let's. Okay, so starting up here, we're going to speak all the activity at the start here will be on router 1. And so I'm going to go back out here to the command prompt. So we'll just take a quick look and see what we have. Can see actually there from that earlier command, but I'm going to just run it here. Show IPv6 interface brief. So we see that all the interfaces, including that loopback interface, which I've already created. So to make sure that this is actually no interface loopback 1. want it to be absolutely router 1. There's nothing on it. So all the interfaces are down. They're not configured. If I do a show IPv6 protocols, and there are no protocols configured. So I wanted it to be that way so that we're actually starting from the same place, so that I'm not hiding anything, and it's good practice. However, what I will be doing, I think I mentioned this in the overview, I'll configure the IPv6 addresses on router 1. I've already done that, completed that task on routers 2 and 3. So it's once it's done one time, it's kind of enough, and I don't want to bore and take up time with that. So I'm going to get started here. Router 1. Let's see, a little housekeeping before that though. One of those things, actually, because I know, is to make absolutely sure that if I type in an incorrect, if I get a slip on the fingers, so that I don't get domain lookups, then go into line console 0, line con 0, and get the executive timeout of 00. This is in a lab environment. Completely okay to do this. If, however, never ever, can't think of any time where you'd want in a production environment executive timeout of 00, which is essentially just leaves it there indefinitely open. Bad, not good. So going to back out of there and go into our first interface, serial 1/0. And just type that out all the way, 1/0. And that interface is going to be our link to serial link on R2. So let's give it a description. The description of PTION, description serial link to R2. And we're going to give that the IPv6 address, 2001 :db8 :caf :2 :1/64. Debug is on. So no, you all turn off debug. I had that on from what earlier walkthrough. So let's see, got the global unicast address. Now let's type in the link local address, IPv6 address, FE80 :1 link local. And it's really important and funny because you're probably asking yourself why, if this is for IPv6, the global unicast address is configured, what's the purpose of the link local? You're going to see the answer to that question really quick here. That link local address is very important. Let's see, then want to, for that interface, no shutdown. Okay, so that'll come up. Now, in case as I'm recording, I have a dog, a beagle, and you can probably hear, I'm guessing you can hear some snoring. Just then, she came into the room here, and the fact that I'm recording, she hears my voice, it's just put her out. So I hope that's not too disconcerting to anybody, but it's just part of the package of what I deal with. So okay, so back to R1. We've configured the IPv6 address, the global unicast address, and the link local address on the serial 1 interface, on serial 1/0 interface on R1. Let's take a quick, let's say, exit back, and let's say show IPv6 interface brief. Okay, there we go. So we've got serial 1/0, link local address, FE80 :1, and the global 2001 :db8 :caf :2 :1. So so let's go now back into interface serial, serial 1/0. I'm going to actually bring up the routing protocol of RIPng. And what's going to be just kind of funny is how few commands it actually takes to do this. Remember in the overview, I indicated that the network command from previous RIPv1, RIPv2, gone. The configuration, in this case, how I'm going to do it is I'm configuring RIPng underneath the interface. So it is IPv6, the command IPv6. I've got another call coming in. Let me get that. Good. Okay. Let's look at and do help there to get an idea. So the next command is actually right there. It's right there. So it's IPv6 RIP. And now we give the process, word, user selected string identifying this RIP process. So we're going to give it a name. And I'm going to borrow and just use what I've been using all along when I do RIP. RIPng. And then the next command, part of the command is enable. Right there. Enable, disable, RIP routing. And we'll be taking a look at some of these others, summary address, metric, offset. Actually, we'll be looking at default information in this particular lab. But the other two here, summary address, not so much in this lab. I'll be coming back to summary address when we're covering EIGRP. So with that, once I press command, IPv6 RIP, RIP IP, RIPng enable. That was it. Now there's actually one step that I failed to disclose was already complete. If I do a show run and include RIP, actually no, that's not what I want. Include IPv, include Unicast. That's the word. What you're going to see is I've already got IPv6 Unicast routing enabled. If that were not enabled, when I attempted to enable the RIPng command there, it would have failed. And to keep that point clear, I am going to disable the IPv6 Unicast routing there. So, and now go back into that interface, 01/0, and enable start the RIP. See, there it is. IPv6 routing not enabled. As soon as and I'm going to do it here so they're not jumping out, do IPv6 Unicast routing. Oops. IPv6. Okay. Go back into interface 0/0. Okay, so now RIP is enabled. And if I do, let's see, I can come out of the exit, and let's do show IPv6 protocols. And indeed, there we go. RIPng. That's the RIP is the protocol here. And the process name is RIPng, and it's running for serial 1/0. Now, remember I said I'd already configured, let me make sure I've already configured the IPv6 address and the same details on R2. So let's take just a real quick show IPv6 interface brief. Make sure that's up and up. Let's do a show IPv6 root. So the only addresses that's in the routing table on R1 are the directly connected routes. So let's go up to router 2 and very quickly, pardon me, let's do a show IPv6 interface brief. Okay, serial 1/0 as its link local address and its global address. I've also got some loopback addresses there that will come into play in just a little bit. And just to make sure, let's see, show IPv6 protocols. So no IPv6 protocols running, including RIPng. So I'm going to go back up, conf-t, interface serial 1/0, and to enable RIPng on router 2, underneath the serial interface, I will type IPv6 router RIP, IPv6 RIP. Give it a process name, and I like to keep the name between all routers that are participating in the same space. So we'll call this RIPng and enable. Again, the IPv6 Unicast routing is already enabled. Do we have anything new in the routing table? Nothing new in the routing table. So what I want to do on router 2 is loopback 2. So do show run interface loopback 2. I have that in the lab. It had this as a gigabit interface, gigabit Ethernet interface. I'm using a loopback interface because the loopback interface is always up, and so I'm using that to simulate this connection that would be going to the accounting department. And so we see that global address there is CAF:3:1/64/2001:DB8:CAF:3:1. So I'm going to go under that loopback interface loopback 2, and I'm going to have that interface that participates in RIP. So IPv6 RIP RIPng and enable. Now, should we see anything different? Oh, actually, let me turn on debug IPv6 RIP. And actually, no. Yeah, and debug IPv6 routing. Okay, let's see, we should have some activity there. While that's occurring, let's see, show IPv6 root. Oh, there we go. Okay, so by turning on that debug, so we actually can see the information. I'm going to turn that off real quick. So we can, one of the things I wanted to point out, see that source port, source address of FE80::1. There's the destination FF02::9. The source port 521, destination port 521. Okay, do we have anything in the show IP in the routing table for router 2? No, all connected routes. So you saw me just put the loopback interface for router 2 into, what I do is show run interface loopback 2, put that loopback into the RIP process. But it should be showing up. There's a network associated with it, but that network is not showing up on R1. You see what the problem is? That's all right. That's exactly it. Shut down. The interface is still shut down. So I'm going to go back over here because I do want you to see debug IPv6 routing. And I'm going to do this twice because I can't remember if I want to see routing or if I want to see debug IPv6 RIP. So back on router 2, going into interface loopback 2 and issuing the no shut command. Now coming back to router 1, there we go. Got a little bit of some activity there. That's not the exact activity that I want. So it is the debug IPv6 RIP. Let's talk about this real quick. So we see here that immediately once I enabled that interface to no shutdown, we had an event where that 2001 db8 :caf:3: was added. So that root was added. So now on router 1, if I do a show IPv6 route, and there it is. Before, we had no routes that had been learned by RIP. The R here stands for, if we go up to the codes in the table, and let's see, there's RIP right there. So the R stands for RIP. And once I enable that interface, the network associated with the network associated with loopback 2 on router 2 now appears in the routing table for router 1. Now what's interesting is, well, isn't there a network on router 2 that's connected to router 1, and that would be the IP address that's associated with the serial connection. So if we look on router 2, do show IPv6 root. All we have, again, learned the directly connected routes. So router 1 has learned its first route. RIPng is running between router 1 and router 2. If I were to go in and add additional routes, which I think I may as well do right now, I'm going to add the loopbacks of loopbacks 10, 11, and 12 to the RIPng process. And over here I'm going to say debug IPv6 RIP. And now I'm going to add those processes. So interface loopback 10, IPv6 RIP, RIPng, enable. Save some keystrokes by doing the up arrow, enable. Okay, so we've enabled RIP on loopback interfaces 10, 11, and 12. And wow, look at that. A lot of echo activity going on back here. I think I can cut that off right now. Or actually, I may have cut it off just a fraction too soon. But I think we'll get the idea here. So the debug that's turned on is the debug IPv6 RIP. Pardon me. And we see again the source, the source that's being used. Notice this, source FE80::2. source FE80:2. The global unicast address is not being used to form these relations. It's not a relationship. Don't want to say the word relationship. Definitely don't want to say the word neighbor, because RIP does not form neighbors. But the source interface, or the source IPv6 address, is the address that's associated with the link local address, not the global address. So in this case, once I added the loopback 10, we got here is the insertion of the address that's associated with that interface. It's inserting the address of 2001 db8:8::10. We had the insertion here for loopback 11, inserted 2001 db8::11. And this is where I think I cut off too quick. Oh, no, fortunate, yay, good. There's the insertion for the loopback on 12, 2001 db8::12. And so now if I look at the show IPv6 route on router 1, I now have 4 routes that have been learned by using RIP. And there they are. They're all indicated by the R. So we have RIP running between routers 1 and router 2. So doing a quick juggle back between what we did, the IPv6 addresses were configured on router 1, configured and verified RIPng on between router 1 and RIP2 on router 2. We verified that the routes from router 2 were propagating to router 1. Those were the addresses that are the loopback addresses on router 2 that were added into the RIPng process. And all of those are now appearing down here in the routing table for router 1. One of the most important things to remember is that in order for the most important thing to remember is for RIPng to work, IPv6 unicast routing has to be enabled. It is off by default. I can configure IPv6 addresses on the interfaces, no problem. However, as soon as I go to use a protocol that relies on IPv6, IPv6 unicast-routing has to be enabled. It is in the iOS in the running config as no IPv6 unicast-routing. It is off by default. So we looked at that on the interfaces. Let's see, let me look at my notes here real quick. I think this is probably a good place to pause, and I want to try and keep the session short. So I'll be back in just a little bit, and where we'll take up then is actually completing the static route between router 2 and router 3, and the default route between router 2 and router 3. Did I say that backwards? I have a feeling I actually said that backwards. Let's see. Look at my notes. It's a default route from router 2 to router 3, and we're going to use RIPng to propagate that information out to, and then we're going to have a static route from router 3 to router 2. Remember that between router 2 and router 3 there will be no RIPng. 5, 4, 3, 2, 1. Okay, so when I left off, we had just completed the configuration of RIPng between router 1 and router 2, and we had the loopback 10, 11, and 12. The networks that are configured on each of those loopback interfaces was also configured to participate in the RIPng process, and we had those routes showing up on router 1 in the routing table right here. So we've got all 4 of those routes showing up. And I'm going to turn debug back on. Debug IPv6 gets ripped by 1 because routing, the debug IPv6 routing is not verbose enough. We should get an update here. Perfect, just right on cue. And I can turn it off already. So what I wanted to show and talk about before moving on to the next step of configuring the default route and the static routes on router 2 and router 3 is the significance of this output from the debug IPv6 RIP. Notice I kind of touched on it, but I wanted to hook it into this particular session. I kind of touched on this before. Notice that it says the source FE80::2, and the destination, we expect that that's the multicast FF02::9. And so it's interesting, why are we seeing a source, the link layer address as the source? And what it is it's very, very important to keep this in mind, that the link local address can be used to reach the next door neighbor, and I'm using neighbor here as in on the same link. So between router 1 and router 2, there is a network link between them for this 2001 DB8::CAF:2::. So we have that link between those 2 routers. It is the link local address that is used in forming this RIP exchange. It's not the global address. In fact, the nodes do not even need a globally unique address to communicate. They will, and the routers will not forward those datagrams that are there with the link local addresses. So this is kind of, it's like, well, it's kind of odd at first. You think, well, I've got the global address there and the link local address is serving the purpose. What's the purpose of the global address? And it's in that very simple statement. The router will not forward any datagram using the link local address. It will only be used in that link that they have in common. To go beyond that link, the global unicast address would be necessary. And IPv6 routers, this is an emphatic, must not forward packets that have link local source or destination addresses to other links. And so that's why we're seeing this source here. Instead of that source actually showing the global unicast address that's configured for serial 1/0, we're seeing the link local. Again, and we see the destination port is the multicast FF02::9, source port 521, destination port 521. And so I wanted to touch on that really briefly because the global unicast addresses will come into play. And I think now might be a good time. Let's actually just take a look. So we know that on router 2, I'm going to do show IPv6 interface brief. So we've got loopback 2 with that address. So let's see, can we ping that address? We can. We can ping the 2001:DB8:CAF:3::1. Can I ping the loopback 10? That's the one that has the 10::1. Can I ping that one? Ping. And I can. Okay. Let's see about the 11, the loopback 11. Can I ping that interface? Ping. That's fantastic. So we've got connectivity to those. Now we know for a fact that on router 2, there's another interface. There's serial 1/1, which is up and up. Can I configure that one? Can I ping that one? And I'm going to think about that from the statement I made earlier about that the routers can't forward packets that have linked local source or destination addresses. So in order to get from serial 10 on router 2, the routing protocol would have to forward a packet that has a linked local source or linked local destination address. So with that, can router 1 ping the IP address that's associated with serial 1.1? The answer should be no. Success 0. Can't do it. No valid route for that destination. And that leads right in really well for the next part of the exercise. We're going to actually enable some connectivity, some routes, so that we can communicate with that link for that 2001 DB8 :feed :1. That's right there. I'll erase it. That network that's on the serial 1/1 on router 2, we're going to enable some capacity here for us to actually be able to communicate with that. Okay, so let's get to where we need to be. So the next thing we're going to do is on router 2. Well, let's do it this way. I'm going to do it backwards from my notes because I want to see something. On router 3, we're going to go to router 3. No, we'll do router. Yeah, router 3, because that's going to be a static route. So on router 3, let's take a look at the running config. Show run. Let's see what we have in here. I want to make pretty sure, so I think I've got okay, now I can go back. I saw something in there on router 3 that shouldn't be. And actually, I'm going to get rid of that. Let's see, show IPv6 protocols. Yeah, I don't want this router participating in the RIPng process. So we're going to go serial 1/0 interface serial 1/0 no IPv6 RIPng enable. I'm going to I'm taking the routing, the RIPng protocol off of each of these interfaces. So we're going to on router 3. So interface loopback 32, loopback 33, and no, there is no 33. 32, 30. Okay, do show IPv6 and brief. Pardon me. Do show IPv6 protocols. That's what I wanted. Okay, interface loopback 31. And interface loopback 30. Do show IPv6 and pro. Ugh. That's what happens when you get in a rush. Show IP protocol. cheat. Show IPv6 Pro. Okay. For some strange reason, once in a while I've had this happen on GNS3 where I know I'm typing a command correctly, and I'm pretty sure I was typing that command correctly, but it wasn't being taken. Either it was a problem with another character in my keyboard sticking and interfering, but that aside. So there, and then we need to get rid of conft do show run include RIPng. What I'm doing is on router 3, this was set up for another lab, and I'm just stripping it down so that there's nothing on router 3. And so we have show IPv6 Pro. Okay, we have no RIPng on router 3. We do have show IPv6 interface brief. We do have a serial 1/0 with a link local address and a global address. We have the loopbacks 30, 31, 32, and 33, and I don't even believe those are going to be used in this particular session. I think we'll be playing with them in just a moment, but not in this particular viewing. Okay, so what I need to do on router 2, I'm going to go back and so on router 2 we're going to be setting up, we're going to do a default route from router 2 to router 3. Now we're going to configure a static route on router 2 to forward the packets to router 3. And on router 2, adding the static route is pretty straightforward. We know the destination is the other end of the link between router 2 and router 3. It's this serial 1/0. That interface serial 1/0 is this IP address, so that is going to be the destination for the static route. So then we come back here to the global config mode and we type IPv6, and I'll get help. There's the command we want, root, and now we need to enter in the prefix, and the prefix for a static route is going to be : /0, and then the next hop, which would be that serial 1/0 interface on router 3, and the address of that is 2001:db8:feed:1:1. So that's that. Now that's configured, but so what we want to do now though is we want to enable that static route that's on router 2 to be propagated into the RIPng process, so that R1, which we proved earlier does not have any capacity to ping the 2001:db8:feed:1:2, which is the serial 1/1 interface on router 2. And even if so, what we're enabling that communication to take the next step. So in order to do that, we're on router 2, we've entered the static route, but now we need to have that static route propagated into the RIPng process, and we do that by saying IPv6 RIP correction, Need to go onto the, and yeah, in order to, I need to, again, I was attempting to do it at global config mode. I need to go under the interface for the serial 1/0 interface, serial 1/0 interface on router 2, and there I need to say IPv6 RIPng default information, and there's originate. And we're going to talk more about that, but that command is then going to take the originate keyword, propagates the default route in addition to other routes in router 2's routing table. If I had selected only the other routes for the loopbacks would be removed. And actually, I can do that. Let's back up and we'll say only. Now we'll come back here to router 2 on router 1. I'm not sure if I can get it in time. See if I got it in time for show IPv6 route. Yeah, they're all still there. I'm going to pause the video for a moment and we'll come back when those have been removed, because the only with the originate command left off, by using only, it is only the static route from router 2 to router 3 that's going to be propagated into the root ng process. And so it may take a little, it will take some time, so I'm going to pause and then we'll come back when that's been cleared. 5, 4, 3, 2, 1. Okay, so now we're back. So one of the things I remembered to do very quickly was to turn on debug IPv6 RIP so that we could get some particular feedback here. You'll notice, remember back on router 2, when the last command that I entered was the IPv6 RIPng default information only. So what that command is saying is that on router 2, only propagate out the default route information that is on router 2 into the RIPng process. So by doing that, immediately the RIPng process stopped propagating out. The interface stopped sending updates for the 10, 11, and 12. Those were those loopback interfaces, as well as for the loopback 2. So they expired. You see that? And so what I should see now when I type show IPv6 root, the only address that's in the IPv6 routing table on R1 is that single default route, which is from R2 to R3. Now, can I now ping? Remember before we tried to ping? Go back here. Oh, can I do it? Cheat. I'll cheat. Ping. Can I do that now? Look at that. Because the default route is now in the routing table for R1, R1 can now ping that serial 1/1 interface on R2. Now, what's the interface on R3? It's 1/1. So can R1 now ping that interface? It cannot, because while it may be getting there, there's no route back. and we're going to take care of that here in just a moment, so that on R3 there is a root back. The packet is probably getting there, so I'm going to kill that. I'm going to trace root. We're going to do the same. ADDD trace root. Let's see where we get to. So we're doing a trace root on R1 onto that interface, the serial 1/1 interface on R3. And this looks like as far as we're getting is just to router 2. Okay, that's good. No problem. So we'll cancel that. Am I going to have to let that time out? You know what? I'll just pause and I'll kill that because it's not taking my. No, it's not taking my. So I'll pause. Okay, so I've issued the no IPv6 RIPng default information only. And so we should see back here on router 1, I'll just let that keep running. I think I have just make sure, debug IPv6 RIP, debug IPv6 routing, debug IPv6. I think that's all I need to do. Yeah, just okay. Oh, we caught it literally just in time. There are those, because of that only being removed, we're now getting those prefixes from router 2 added back into the routing table on router 1. So if we do show IPv6 route, now we have not only the default route that's been propagated in on router 1, we now have those loopbacks from router 2, and so we're going to say IPv6 RIPng default information originate. Oops, slow down. Originate. Now come back to router 1. Now what should happen now is we should see any routes that are on router 2 that are being originated there on router 2, those will continue to be propagated into RIPng, and so we shouldn't see. Yeah, there we go. So we're seeing pretty much the same information as before. So we said show IPv6 RIP, show IPv6 root. Perfect. Okay, there we've got the default route from router 2 and the loopbacks from router 2. So all that's being propagated in. So now we're going to go to router 3, and we're going to do a static route from router 3 to router 2, and that's going to close our loop. Remember back on router 1 when we attempted to when I attempted to ping, see if I can get back to it. When I attempted to ping this 2001 DB8 feed :1::1, it failed. And I'm going to have to let it time out. And the reason it is that it's perhaps getting to that interface, to that 2001 DB8 feed :1::1, but there's no route back. So now what we're going to do on router 3 is we're going to actually set up a default, a static route from router 3 to router 1 to the 2001 DB8 CAF ::/48 prefix on router 2. So we're going to go, it's real straightforward again, IPv6 root, and we're going to say db8 colon, no, oops, getting ahead of myself, 2001 db8 colon calf colon colon slash 59 2001 colon db8 colon feed colon 1 colon colon 2. Okay, now let me make sure do show run include IPv6. Just looking to make absolutely sure that IPv6 unicast routing is enabled, and it is. There it is right there. So with this static route now, can we now ping from router 1? Look at that. Because of the static route on router 3 into router 2, we are now able to we have a full loop. So that's magic. To me, that's magic. I mean, so, okay, so let's see. What do I want to do? I'm going to turn off debug. I'm going to take a look at the IPv6 routing table. Routing table is exactly where it was before. We still have those 4 IP addresses. We can ping from router 1 to router 3. Can router 3 now ping router 1? Well, let's see. So we're going to, let's do a write mem before we forget. Major, I just caught myself when I was on the break there that I had forgotten to commit these changes, and write mem. Okay, so those changes are there. Let's see. So we're going to say from router 1 or from router 3, can we do a show IPv6 int brief? I don't remember these addresses, so I have to look them up. Router 3, can we ping the serial 1/0 interface on router 1? And we can. So we have full loop of connectivity now from router 1 to router 3 using a static route from on router 3 into router 2, and a default route from router 2 to router 3. And if we do, let's see, if we're going to come down here, we're going to say show IPv6 route RIP. Nothing there. Shouldn't. That's right, because RIP isn't running on this particular, on router 3. Let's try it here. Show IPv6 route RIP. Interesting. Why is that? What do you think? There's a reason. But when we come over here, show IPv6 route RIP. Now we see isolated all of the exact routes that are being propagated into RIP. Okay, let's see. What do I need to do next? Oh, let's take a look. Show. We're going to take a look at the RIP database. IPv6 RIP database. And then here we're seeing all the IPv6 entries that are installed. We get the prefix, the metric, the interface, that how the route came in, and the link local address, and the timeout when that will expire. So yeah, all good stuff there. Let's see what's next. That's it. So I mean, so again, one of the things it's really important. Just how. Oh, I know what I forgot. I need to go and I need to say show IPv6 RIPng next hops. Okay, so the next hops on router 1 is the FE80::2, which is the link local interface on router 2. Don't believe me? So we'll take a look. We'll say show IPv6 int brief. Remember, all of the interfaces on router 2 have the FE80::2. So let's take a look and look at that same command, show IPv6 RIPng next hop, and the next hop on router 2 is the link local address for router 1. Okay, that's pretty much it. As I said before, the important things about IPv6 with RIPng is that I'll bring back up my notes here. It's distant vector. We've got the same hop count limits that we've had always before. That the process is not enabled by default, that you have to enter the IPv6 unicast routing, that the processes allows multiple process instances because you're giving each one a different name. And if you're going to be running multiple RIPng processes on the same interface, additional configuration is necessary, and that additional configuration includes some activity around assigning ports to each of the instances, allowing the multiple instances all to attempt to run using port 521 problematic. It will cause much headache. So I think we accomplished the objectives. Actually, you know what? Actually, we need to do one thing more. I'm going to go back here and let's start here with, let's do a capture from R1 to R2. And it takes just a moment. Let's see what we get right away. I just want to take a look at one of the, there's CDP, and there's RIP, so I can stop there. That's enough. So I want to take a look at, okay, so there's the time, there's the source. Source was FE80::1. The destination was the multicast address for RIPng, which is FF002::9. And the protocol was RIPng. So now we can go back in here and we're going to take a look to see the source, the destination. See, for the UDP, for that the source port was 521, the destination port was 521. And RIPng, and there's the routing table entry and the prefix that's to be that's being sent in that update. Now the fact that it was that entry, that 2001 DB8:CAF:2 was already in the database, it's there's no update to be performed. It just resets the timer for the expiration. RIP will update the timer and the count will start over again. Okay, so let's close that. I think what I want to see happen, no, I think that's pretty good. So we've accomplished the objectives. We enabled debug, used a Wireshark capture to look at those details that are underneath in RIPng, which are not readily seen in the actual configuration feedback. You need to have debug on, but having debug on in a production environment is not advised unless under extremely low loads on the router. So we're using debug in a lab environment. Just looked at a brief Wireshark capture. There will be many more Wireshark captures in the future, so we can get underneath the configuration syntax to see what's happening in iOS. Also, in this particular RIPng configuration, we did configured the IPv6 manually. We configured the IPv6 addresses manually. We enabled RIPng on R1 and R2. And in doing that, we discovered that on the segment between R1 and R2, that it is the link local address that is the source and it's the source that's being sourced interface, that's source IPv6 address that's being used to complete the RIPng exchange between router 1 and router 2. Then we did a default route from router 2 to router 3. We propagated that route out two separate ways. First, we propagated that route out using only as the last word in the command, which resulted in the loopback interfaces and the addresses associated with them from router 2 being removed on the routing from the routing table on R1 and only having the default route present in R1's IPv6 routing table. We then went back to R2 and removed the syntax for the default information only and changed it to default information originate, and that allows both the default information as well as routes, the routes that are expressly configured on the R2 to also be propagated out. So if we come back real quick, and this is literally wrapping up here, on router 1, we look at, just look show IPv6 route. Actually, let's do it this way so we can trim it down. And we see we've got that default route. And then we have those 4 addresses that were learned from router 2. Well, great. So I think that's going to wrap up everything on the RIPng. If there's something else that comes up, I can always add to. But I think that's a good place to wrap up this particular lab. We accomplished the objectives, seeing how RIPng can be configured, how to verify that RIPng is configured. Again, some of the same concepts that are being applied in this particular session, we're going to see them again with EIGRP, OSPF, those IPv6 those protocols where IPv6 is being used, and where we'll actually be configuring the protocol under the interface. In OSPF, then we're going to step into address families, where you'll see also something very similar, but it's occurring underneath the interfaces. So again, thanks for viewing, and this is a great lesson for me because I'm able to review this verbally, hear myself, see what I'm doing, and catch mistakes, and also come back and learn some more. So again, thanks for viewing, and next video will be EIGRP, and we will be digging deep into EIGRP. There will be probably 4 videos, maybe even 6 on EIGRP. Then we'll see where we go from there. Thanks again.